Hello, welcome to Unit 6, Lesson 4. I'm Professor Blackman. In this lesson, we're going to be talking about radical expressions. We're going to add them, subtract them, and multiply them. A little more in detail of multiplication than what we've done in our previous video. All right, let's go ahead and get started. So here on this slide, we're going to be looking at adding and subtracting rational expressions. So what we're going to do is, as we look at them, we're going to look and treat this like we're adding different like terms. And so since this is the cube root of y and cube root of y, and they're both cube root of y, you can treat that kind of like a x. So like 4x plus 9x, that's just going to give us 13 in our variable, which is the cube root of y. Okay. Here, as you see, these are all the root 10. So we're going to do 3 minus 8, which is a negative 5, plus 7 gives us 2. So this is 2 root 10. And root 10 can't simplify because that's 2 times 5. Here, we look at them and they're not the same, so we can't do anything about it. But we know the square root of 27 is 9 times 3, so that becomes 3 root 3. So we can rewrite this as 8 times 3 root 3. And then 8 times 3 is 24 root 3 minus 3 root 3. And so that gives us 21 root 3. So same thing here, we got to make sure we put these in the same roots. Well, let's look at what square root of 45 and square root of 20 become. 45 is 9 times 5. 9 is a perfect square, so this becomes 3 root 5. 20 is 4 times 5. So now you can see that they both have that root 5 underneath, which becomes 2 root 5. So this becomes 8, 3 root 5, plus 7 times 2 root 5. And 8 times 3 is 24 root 5, plus 7 times 2, which is 14 root 5. When we add them together, we get 38 square root of 5. So let's look at some more examples. All right, in this one, we're going to add or subtract as well. And again, we don't have the same roots here, but let's see if we can get them in the same roots. So we have cube root of 16 and cube root of 54. Well, 8, this is 8 times 2, which 8 is a perfect cube. So then that becomes 2 cube 2. Now, since this is a 2, I'm going to try and see if there's a 2 in here. There is, and that's 27 times 2. Once you get 1, you know that if we want to add or subtract them in order for them to be the same, they both have to have that same 2 underneath there. So this becomes 3 cube root 2. So now we have 3 times 2 cube root 2 plus 3 cube root 2. So 3 times 2 is 6, so that's 6 cube root 2 plus 3 cube root 2. And 6 and 3 would give us 9 cube root 2. Okay, let's do the next one. So we have square root of 4, which is 2, plus square root of 18, that is 9 times 2, so that's 3 root 2, plus 3 root 2. And as you see, they're not like terms, they don't have the same root 2, so we would leave it just like that. All right, let's look at some more. So here we're going to multiply, so we're going to apply. So the distributive property is when you have something outside a parenthesis, everything inside the parenthesis needs to be distributed to. So that becomes AB plus AC. So what we need to do is multiply this times this and then this times this. So that's negative 4. Square root of 3 times square root of 3 is square root of 9 plus 6 square root of 3. Okay, and so then this becomes negative 4 times 3 plus 6 square root of 3, which is negative 12 plus 6 square root of 3. And here we're going to leave it just like that because those are not like terms, so they cannot be added. Okay, same thing here. We're going to distribute. You can see that they're all cubes, so we're able to multiply this. So this becomes the cube root of 2a to the third plus the cube root of 16a to the third. Okay, so as you multiply that in, okay, and so then this becomes that a comes out because 3 divided by 3 is 1, so that's a cube root of 2. So as we look at the 16, the cube root of 16 is, there the cube underneath it is 8 times 2, so it becomes 2 cube root of 2. And we already know the a to the third is just going to equal a. So then when we put those together, that gives us 2a to the cube root of 2. The a to the third comes out completely, then the 16 becomes 2 cube root 2. And now if you look, we have a cube of 2 and 2a cube of 2. So when we add those together, that's 3a cube root of 2. Because they have together the a cube root of 2. All right, let's look at another example. So in these examples, we need to multiply everything in the first term by everything in the second term. Let's start by multiplying the first term by both terms. And so that gives us the square root of 9 plus the square root of 6. Let's multiply the second term by everything. That gives us negative square root of 6 minus the square root of 4. And if you notice, our middle terms cancel out. So then we get the square root of 9, which is 3, minus the square root of 4, which is 2, which gives us a 1. All right, let's go ahead and do the next one. So multiply that. That gives us the square root of 64. Multiply that, and that gives us negative 2 square root of 40. Right here gives us the positive 2 square root of 40. And here gives us negative, and be careful when you do this because it's 2 times 2, which is 4, square root of 25. Our middles cancel out again, and then we end up with 8 minus 4 times 5, 8 minus 20, which is a negative 12. Let's look at some more examples. All right, in here, same thing, 7 times 7, 49. 7 times negative square root of 5, negative 7 root 5, plus 7 root 5, minus square root of 25. And so our middles cancel out again, and we end up with 49 minus 5, which is 44. If you notice on the previous 3 examples, the middle have canceled out because this is a application of difference of squares, because we have a sum and difference of 2 binomials, and we end up with a difference of squares. All right, so here we end up with square root of c squared minus square root of cd plus square root of cd minus square root of d squared. Middles cancel out, and we get c minus d. All right, here's our last one. This would be a little different because, as you notice, these are different, so it's not going to be like the previous 4 examples where the middles canceled out. 3 times 2, 6. 3 times square root of 5, 3 root 5. On the inside, we have negative 2 root 5 and a minus square root of 25. Then we end up with 6. 3 root 5 minus 2 root 5 is plus 1 root 5 minus 5. And 6 minus 5 gives us 1 plus root 5. All right, and the next one, multiply, and we get 2 root 9 plus root 3 plus 2 root 3 plus 1. So this becomes 2 times 3. Root 3 plus 2 root 3 would be 3 root 3 plus 1. 2 times 3 gives us 6 plus 3 root 3 plus 1. And 6 plus 1 gives us 7. And bring down your 3 root 3. All right, that's all I have for you today. Happy studying.